Hello everyone. In this lesson, we're going to continue with the overall topic of trigonometry, and specifically, we're going to talk about evaluating trigonometric ratios. As I've said before, this trigonometry stuff is quite important, so let's recap. Now, the trigonometry we're doing deals with right triangles, and in each right triangle, we're dealing specifically with one of the angles that's not 90 degrees, right? So let's say this one, call it theta. And then relative to that angle theta, remember we give special names to each of the three side lengths. So for example, the side length opposite the 90 degrees, right? This side length right here, we call that the hypotenuse. And then the side across from theta, the angle we're working with, this side, we call the opposite side. And then the shorter side that's touching this angle that we're working with, so this side, right? That one's called the adjacent side. So opposite, adjacent, and hypotenuse. And remember, people figured out that for a given angle, different ratios between these three sides are always the same. And we can use those ratios to calculate things, right? And so we learned three basic ones. We got sine of theta, which is opposite over hypotenuse. And remember, the word SOHCAHTOA tell us these ratios, right? So that's so. And then we got ka is cosine of that angle is adjacent over hypotenuse. And then toa, T-O-A, that means tangent is opposite over adjacent. So again, we use these ratios to calculate things about right triangles. Now, before we move on with this lesson, I'd like to point out something. In all the problems that we did in the previous lesson, note that we knew the angle measure of the angle we were working with. So this angle measure was known info. We knew exactly how many degrees it was, right? And then we also knew one of the side lengths. So we knew exactly how long one of the sides was. And then the unknown, the thing we were trying to find was a second side length. So like this length, let's say, and we give it a variable because that's our known, right? So again, we knew one of the angle measures. We knew one of the side lengths, and our unknown, what we're trying to calculate, was another side length. Now compare all that, what we did in the previous lesson, with the type of problem that I want to talk about in this lesson. So in the problems that I want to show you in this lesson, we will know multiple side lengths. So we will know the specific numbers for multiple sides, right? On the other hand, the angle that we're working with, the specific degree measure for the angle will be unknown. So again, our angle will be an unknown in this situation. But it turns out there's still some trig we can do even if we don't know specifically what this angle is, specifically how many degrees it is. So here's an example. It says, consider the triangle below, evaluate the given expressions. So let's process that. First of all, it's a right triangle that we have, so we can use the trigonometry we've learned. Like I said, we know all three side lengths, and the angle is unknown. Now it says evaluate the given expressions. So what does that mean? Well, first of all, expression means like a math word. I mean, these are expressions. And then evaluate means find the value, right? Figure out what number it equals. So we're going to figure out what is the sine of that angle. What does that equal? That's what evaluate means. Another expression, tan of theta, tangent of theta. What does that expression equal? What number does it come out to? And if you think about it, we don't even need to know how many degrees this angle is to figure out what the sine of that angle is and to figure out what the tangent of that angle is, because we have all the side lengths needed in that ratio, right? Because if you remember SOHCAHTOA, sine is what? Sine is opposite over hypotenuse. And then we have those sides over here, right? And by the way, we should start off by establishing what those sides are. Let's see, hypotenuse is across from the 90-degree angle, so that would be 60 is the hypotenuse. And then across from the angle we're working with, theta, that's the opposite side, right? And then, of course, the remaining side is the adjacent side because it's touching the angle here. So now, sine theta, what does that evaluate to? Opposite over hypotenuse, so 51 over 60. And this problem is only asking us what this whole thing comes out to be. So we're done. This right here is our answer. And you can leave the answer in fraction form, or you can find a decimal approximation if you want. So that ratio actually is exactly 0.85, it looks like. So that's another way to write our answer. And so that's the value of the first expression. Notice that it's not asking what the angle measure is. Now, calculating angles is important, but we won't do that yet. We'll do that in a different lesson. So now, here's another expression that we need to evaluate, right? Tangent of that unknown angle. And again, according to SOHCAHTOA, what is tangent? Tangent is opposite over adjacent. So then the value of the tangent ratio, right, what that ratio comes out to be is opposite is 51 over adjacent is 36. And again, we're done. That's our answer. As a decimal, looks like that's 1.416 repeating. So that's mostly it for this lesson, although a word of caution. So a word of caution, here's an example that's asking us to do exactly the same thing as the previous example. It says evaluate the given expressions. It's a right triangle. We have all the side lengths, right? However, what's different? Notice that the angle measures that we are working with are not labeled with variables. So there's no theta here, there's no theta there, no variables inside the triangle, right? Instead, the triangle's vertices, the points, are labeled with letters. And of course, sometimes we deal with shapes like that, right? That's a common thing in math. And so we've got these expressions, cosine of p and tangent of q, that we're trying to evaluate, that we're trying to find, what number do those come out to. And you have to be careful because each expression deals with a different angle. So the first one, cosine p, that deals with the angle p, of course, so this one, right? But then the next expression, tangent of q, that deals with a different angle. Q, right? Q is not P, Q is over here. And if you think about it, our labels for the sides depend on the angle we're talking about, right? Adjacent, opposite depend on what angle we're talking about. So actually hypotenuse is the same. Hypotenuse you don't need to worry about because that's always across the 90-degree angle. So 32 is the hypotenuse. But again, the other two sides you have to be careful because they're different for P and Q. So angle P, for example, first of all, cosine is adjacent over hypotenuse. Although let's just label all the sides. So where is adjacent? Where is opposite for P? So opposite across from P. So 28 is opposite, right? And then touching angle P here is the 11. So 11 is adjacent for P. And now we can be like, okay, cosine for P is 11 adjacent divided by hypotenuse is 32. And that's fine, that's our answer. But now for Q, again, Q, that's different. 28 is not opposite Q. 11 is not adjacent to Q. So for Q, we have to relabel the triangle. Let's erase the opposite, erase the adjacent, erase this, that. And now we can think about what's opposite and adjacent to Q. And by the way, what's tangent? Tangent is opposite over adjacent. So where are the sides for Q? Across from Q is over here. So 11 is opposite now. And then next to Q, which one touches Q? The 28 does, right? So adjacent. And now that we've switched over to looking at things relative to Q, we can evaluate this expression. So opposite is 11 now, divided by adjacent is 28 relative to q. So again, when evaluating these expressions, just be careful what angle they're asking about, right? P in one case, Q in another. And be sure to establish the correct sides. Where is opposite, where is adjacent? That's it for this lesson. As always, if you have questions or feedback, feel free to contact me.